Hello, everyone. Thank you for having me. I'm super excited to be here. And today I'd like to tell you a little bit about our Vagrant journey, what we achieved with Vagrant and Packer. So the story begins with the fact that people used to pay a lot of attention to production environments, and that's kind of fact it's hard to argue with, as this is how you make money. So that's kind of obvious decision that you put a lot of attention to your production environment. But the truth is, you need equally good environment on your local machine. So the better the environment you run on your laptop is, the better the overall quality you deliver is. And you need some kind of a playground, so you're not afraid to do stuff that potentially may break things. So why should you really care about that? So the fact is that without any kind of standards around how local environments look like, people used to do things on their own, and it doesn't really work in the long term. So with Vagrant, we have the overall good quality, and we are sure that everyone runs the same. There's no like apples, oranges, and bananas. There's just apples. It also allows us to onboard people really fast. So when the new person joins the team, all he or she needs is basically a Vagrant image. You don't have to be aware of all the bits and pieces that are inside. That's pretty much like a super quick start for a newcomers. So all you need is a Vagrant box, and that's pretty much it. What also comes with Vagrant is that you're not afraid to break things if you're not super confident about the code you are going to deliver to production. You can triple check that. You can break things on your local machine, and no one will be mad at you. That's your local machine. And you can do experiments. If you want to do something that's potentially dangerous, you can deploy that locally, and if anything breaks, whatever, nothing happened. You can start over anytime you need it. And this is another benefit that Vagrant provides us. So before Vagrant, people used to put a lot of stuff into a zip file in our company. So basically, we run content management systems. So people used to deploy stuff there and shut down the service, put it in a zip file, and upload that to a central server so everyone can download that zip file. And the idea is great, so you can basically build it once and ship it for everyone. But the problem is that it very often leads to a situation that looks like this. And that's kind of obvious next step if you allow to do such kind of things. As people will copy the original zip file over, change something, you have no idea what's inside, and you basically rely on stuff that contains things that you might or you don't want to have on that particular instance of our CMS. But thankfully, things have changed recently. And things have changed as the overall complexity of a platform we used to build increased significantly. There's much more moving parts. There are services around you need to integrate. So there are search engines. There are things like CDN. So there's plenty of stuff around you, and you need to somehow integrate with all these tools. And that approach with zip files won't work long term. As you have no idea what you're doing, and you're on local machines, you're doing things completely different than you do in production. There are a couple of new technologies that emerged over the last few years. Vagrant was released, if I recall correctly, 6 years ago. Docker itself is like 3 years old, so there are plenty of possibilities to implement local environments these days. And we've been looking at these solutions, and we have defined a couple of areas we'd like to focus on. So the first thing is isolation. So if I work for project A, and then 3 months later, I'm moving to project B, then these two environments should not interfere with each other. We want to achieve reliability, so the environment is stable and it is built the same way as all the other environments. The environment is also complete, so you run exactly the same services as you run on production, so the logical architecture stays the same. We should be able to upgrade that environment easily, and the environment you run on your laptop should have a decent UX, so it should be something different than a wiki page with like 30 points you have to go through to install something on your local machine. We decided on Vagrant eventually, and some of you may wonder, why not Docker? So in our case, it was like there are some architectural principles in a CMS we run, and one of them is that no matter what kind of asset you deploy, it is stored in the same repository. So application, configuration, and all the content lives in the same repository. So if you'd like to put it into Docker, it basically means that we have to extract that outside of the container. So pretty much nothing leaves in the container itself. So that's not ideal. We also do not run Docker in production. So what's the point of running Docker locally? We'd like to have as close as possible. We have to be as close as possible to the production environment. And moreover, the majority of the team runs Windows. So the experience of Docker on Windows is not really great. So our Vagrant journey started with something like this. That's a typical Vagrant file. There's nothing really special here. If you ever had a chance to use Vagrant for like local environment, this is probably the Vagrant file you had, or a very similar version of that. And that's kind of OK, as there's nothing extraordinary here. But there are a few pros. So we have a full application stack in Vagrant. It is provisioned exactly the same way as any other environments. We use Chef for deployments. You have all in one box. For some of you, that might be a disadvantage. But considering the complexity of our application stack, that's the only way we can actually implement things. As like the typical environment to run these days requires like 6 to 8 gigs of RAM. So if you'd like to have a separate VMs for that, we have additional overhead of running multiple operating systems. That's not really a viable option for us. And we manage the Vagrant project the same way as we manage Chef cookbooks. So basically, we use Berkshire for dependency management. So alongside Vagrant file, there's also a Berkshire file in the Vagrant repository. But there are a few cons as well. So the first attempt we made was based on a very basic box. So there was like a clean operating system and nothing on top of that, which basically means you have to wait like 2 hours for the Chef to complete. There's plenty of stuff we have to download, and there's like some time that needs to be spent on initial start of the CMS, so that's not a great approach. And every single developer was going through the same procedure. So if we have like 10 developers in a team, we have to multiply that 2 hours by 10 developers, and that's a waste of time, basically. And the overall user experience was kind of poor. Users started complaining that it takes too much time, it's not really convenient, maybe those zip files were better. So we decided to address this problem somehow, and we went for custom boxes. When we started our journey with Vagrant, there was no Packer around. So the first project that allowed us to build custom boxes was a project called Viwi. It was released, the first release was in 2011. 2 years later, Packer was released, so we switched over to Packer. But these tools are not enough. We have to have something more that underpins the whole process, as that's just building. We build boxes. We have to also release them. We have to distribute them. So there's a couple of extra problems we have to solve. So in our case, we decided to implement something on our own. And we created a very super simple process. It's like everyone can do that in like a day. So we have an in-house tool that goes through 3 phases. And the first phase is prepare. So we download all the dependencies, we download the base box, and possibly all the files we need before we run Chef on top of that. The second phase is build, which actually runs Packer. And the third phase is release. So we release the box, we export it, and we upload that to our build artifact server. Unfortunately, this process requires a physical hardware, as you can't. We use VirtualBox as a virtualization platform, as we have a team that of various. We use various operating system across the whole team. So we have OS X users, we have Linux users, but the majority of the team runs Windows. So we have to have a common platform that works everywhere. And we need to have a physical machine, as you can't run VirtualBox on AWS or DigitalOcean or whatever you're going to use. Here's how the process looks like. So we have a Git repository that stores all the Packer files, which is basically a JSON file. Whenever you push something to that repository, a build is triggered on Jenkins that actually delegates the work to a physical slave. The first thing that we check is that the box we are going to build is, if the box we are going to build is already there. So if it's already on the artifact server, we just end the processing. If not, then we go through these 3 phases, and eventually we create a tag in that Git repository that that particular box was built, so we can get back to that anytime we need it. And we also upload that to the artifact repository. This is how the Packer file looks like. Again, this is nothing extraordinary. The only thing that's really interesting here is that we run some post-processing in a provisioner section. So in most cases, there are more than one element under the provisioner section. So we run Chef first. That's kind of obvious. And finally, at the very end, we run some post-processing to reduce the size of the image. So we write zeros to all the free space so it compresses better, or we remove some temporary files, we remove some log files, and things like that. The problem with such approach is that it takes time. In our case, it's between an hour and 3 hours to build the whole environment. And second problem, which is actually no longer a problem, but for a very long time it was a big problem for us, that Packer destroys everything on error. So if your Chef run wasn't successful, the whole work that has been done so far is gone. Or if something went wrong during that post-processing and non-zero exit code was returned, the whole work is gone. You can't check what was wrong. You can't verify what was the problem, as the image is gone. And if you encountered similar issues, you probably know that issue. It was a request to implement that for 2 years, to implement some kind of a flag that allows you to stop processing and keep the image so you can log in and see what happened. And that's extremely frustrating. That's super frustrating at the very beginning, as you spend days, not hours, days, on trying to figure out what was wrong and how to make it happen finally. And it's even more frustrating when it happens during box export. So after 100 attempts, you finally build the box, and you realize that something goes wrong during the export. So the build was successful, but for example, you run out of disk space. That's super, super annoying. So we decided to implement a couple of things that will allow us to bring this process to a new level. So first of all, export temp variables. So it was kind of hilarious that I personally spent a week trying to build an image, and when finally everything was good, everything was green, 3 hours later, by default, Packer exports the box to temp directory, and our temp directory was a separate mount with 2 gigs, and the image was 8 gigs, so you know what happened. You can also use custom environment variables for building. So for example, if you build stuff on OS X and you build stuff on Linux, most probably some stuff is in different directories. So you can just export a variable and import that in Packer file. So the Packer file stays the same no matter what OS you're running on. Moreover, if you use Chef and during the build, you connect the temporary node to Chef server and you set some constraints on environment level, it's great to export that environment as well, as otherwise you won't be able to get back to that and see exactly what was built, as all you have is like a tag in a Git repository and you have no idea what was defined in Chef on environment level. You should treat also the Packer repository as a regular project. So if something gets released, there's tag is created in that repository. And you should also pay a lot of attention to making sure that the box is as small as possible. And as I said before, in our case, it's like roughly about 10 gigs right now. But you shouldn't go too far with this. For example, we decided to over-optimize the disk space, so we removed tons of files, and one of those files were license files. So eventually, we built a box with a service that can't start because of that, because that license file was missing. And if you're looking for great examples, there's a repository with all the base boxes we use. Chef guys build on a regular basis. They build all base boxes for all operating systems you can imagine. So that's kind of nice. There's also a lot of scripts you can use in your own project. All right, next thing. I already said that, but in our case, it's not really a viable option to have more than one VM. It's like way too much overhead, and without like 32 gigs of RAM, you can't run it, so it's kind of pointless. So we decided to pack everything onto a single box. We also, for a while, we used incremental boxes. So to reduce the build time, we decided to build stuff that comes in every single project, and we, instead of relying on the base box and building on top of that, we had like the intermediary level that allows us to speed up a few things. But the problem with this is you have to maintain that as well. So eventually, or actually recently, we decided to actually do deployments from scratch. Every single time we create a new version of that particular box. And the biggest advantage of that is you deploy from scratch and you test that deployment from scratch. Some of you may do such things on a production, but if you work for a company that is a bank or an insurance company, they don't want to do such things in production. So that's great that we can pick up bugs really quickly when we deploy from scratch, as otherwise those bugs won't be seen as we used to deploy stuff incrementally, so we deploy 1.0 and we deploy 1.1 on top of that. We never deploy like 1.1 from scratch, and that allows us to pick up bugs really, really quickly. When it comes to box distribution, there are three options basically. You can use HashiCorp Atlas. You can build your own Vagrant cloud, or it's no longer a Vagrant cloud, but if you Google that, it's pretty easy to build your own Vagrant cloud-like service. Oh, and also you can use some third-party services like Artifactory, for example. So after all these changes, we have a Vagrant file that looks like this. The significant change here is that we no longer rely on base box. We have a custom box. So we have a custom repository. We have our internal one that distributes all the images. So whenever you start Vagrant on your machine, you have like all services in place already. You no longer have to wait those 2 hours to get up and running. So the goal was that Vagrant app provides complete environment, and for a while, we unfortunately didn't notice that we actually removed those licenses files. So you have to run Vagrant provision after Vagrant app to get up and running, which is like better, but not ideal. And we also ensured, of course, that all services are in place. Lastly, the last part of the Vagrant journey is ongoing provisioning. So once you have the box, the custom box, you have to have a way to deploy stuff on top of that. So we'd like to use Chef. We'd like to implement a way that developers can run Chef cookbooks on that local environments as well, the same way we do that on production. We also would like to preserve all the habits that developers have. So if you use, like we implement all of stuff in Java, so if you use Maven full deployments, we'd like to preserve that. So if you do Maven clean install to deploy stuff on Tomcat, for example, it should stay the same way. We didn't want to violate that. Moreover, the goal was to keep all the configuration files. So if I connect to localhost 8080 to do something, it should stay the same way. So we use a lot of forwarding in Vagrant file. And the overall experience should be that the environment feels exactly like production. And it should also be easy to upgrade. So the provisioning process used to look like this. So you pull all the changes out of Git repository, you run Berk's update to update all the cookbook's dependencies, and then you run provision to run Chef on your local instance. But actually majority of the team sees that command like this. Some of them even sees it like this. And this is how it looks. It's way too complex. There's so many ends. Some people wonder what's the Berk shelf is for. Why do I have to run provision? Why do I have to run Berk's update sometimes? And sometimes I don't have to do that. So people used to see Vagrant as this truck. So it's featureful. There's plenty of things you can do, but it's kind of slow and heavy. And the expectation was like this. I want to roll things out really, really quickly. So we've been thinking about what can we do about it, and we identified that the biggest problem was that we have a very, very long run list in Chef. So we have tons of recipes, as we have like 10 or 11 services on every single Vagrant box, and it takes like 15 minutes to build the box, to provision the box. So we decided to use Rake. Rake is like a make for Ruby, for those of you who are not familiar with that. So you can basically define, so Rake is typically used as a build support tool. So you can, for example, download dependencies, build the code, and upload that somewhere. So it's kind of like Maven in Java. But we decided to use that, and there's a very good reason why we decided to leverage Rake here. So we'd like to automate repetitive tasks. So if I execute that git pull, Berk's update, Vagrant provision like 10 times a day, why do I have to type it every single time? We also would like to reduce the overall complexity. We have to have a single tool that allows us to interact with Vagrant boxes. Also, the Berk shelf complexity. Not everyone is really familiar with Chef and don't really understand what Berk shelf is for and why do you have to run it, or maybe I have to modify the Berk's file first to do some stuff. And as I said, even if you change, I don't know, you added a single rewrite rule to your Apache server, you had to wait for 15 minutes to deploy that change, as the run was like, nothing has changed, nothing has changed, nothing has changed. Oh, there's a new rewrite rule, deploy that. Nothing has changed, and so on, and it took like 15 minutes. And it was kind of painful for such a simple change. And finally, we had it was couple months ago that we had like nearly 800 resources on our resource collection in Chef. Right now it's nearly 100 resources, and when you get things like 8 resources out of 800 resources got updated, what it really means. So we did a few changes in the Vagrant file. Vagrant file is nothing more than a Ruby file. So we added a few extra elements, and those extra elements are in the provision section. So we have a run list here. That's a Ruby hash, so we have a couple of predefined keys. In our case, we decided to split it based on the service. So we have like an empty run list, which is the default one. We have a run list for Apache. We have a couple of run lists for Tomcat. And what we do here is we read a file called .runlist. There's a single string in that file. We read that, we put it as a run list, and then we move on with with the rest of the Vagrant processing. So whenever you do any command, like Vagrant app, Vagrant provision, this code gets executed as Vagrant file is evaluated as Ruby code. And this is how the first part of the rake file looks like. So we have also here a definition of services we run. We also have three namespaces here. The first one is Bergshelf. So in Bergshelf, there's like 2 ways you can install all the dependencies. When there's no bergsfile.log file, you have to execute bergs install. And when that file is in place, you have to execute bergs update to download dependencies. Moreover, we use the file resource here in rake. So whenever rake uses timestamps to validate that, so whenever bergsfile.log is newer than bergsfile, that code is not executed. So it gets executed only when something has changed in the bergs file. So we can basically skip the Bergshelf part. We also do bergs vendor, which saves all the cookbooks to a separate directory. For some of you who do Vagrant and Chef, there was a plugin called Vagrant Bergshelf, which does that, but over time, that code was ported to Vagrant itself, or actually some of them was ported, so you can use that. You no longer need a plugin to achieve the same goal. The second namespace here is namespace called Vagrant, when we define very simple actions like up or provision. Provision action depends on that bergs file log file. So if we do like rake Vagrant provision, then first we validate if the bergs file log is newer than the bergs file, and if it is, then we skip. Otherwise, we download the dependencies. And also, finally, we have a provision namespace, which is actually the point where we save to that .runlist file. We save that string out of the service definition on top of that file. We save that string to a file, and then we read that in Vagrant file. So it sets the run list to a very small subset of the entire run list we'd like to run. Here's the second part. We also have a couple of helpers. So before we implemented that, there was a long Confluence page that you had to go through and execute a few commands like Vagrant plugin install whatever, Vagrant plugin install whatever too, and things like that. Right now, all you have to do is like rake init, and all those plugins will be downloaded automatically. We also have a helper that removes all the boxes. So whenever we release a new version of the box, it gets downloaded and is stored in Vagrant cache. But it takes space, and when the new box is already on, you can get rid of the old boxes to reclaim some disk space. All right, so that was it. So that was the reward after using a bit of rake. And this is how it looks in practice. So we have a much simpler CLI to interact with. So whenever you execute rake -t, you get all the actions you can execute. So for example, when we execute rake provision HTTPD, we deploy just Apache configuration, and you no longer have to wait for all the other services, as you exactly know what happened already. And if you don't care about a particular service, you can provision just the one you care about. And the provisioning time is no longer 15 minutes. It's like 11 seconds right now. It's actually like more than like 15 than 11, but it's still much, much better than like 15 minutes of waiting just to realize that you updated a single line in a single file and you restarted the service afterwards. We also use console as a service discovery in production, and we also would like to run that on Vagrant. So some of you may be wondering, what's the point of having service discovery on Vagrant, as that's all localhost? So why should I care about that? So we'd like to have same thing everywhere, so we decided that console is really required, as we use DNS interface of console to interact with services. So there in our configuration file, there are references to console domain, so things like tomcat.service.console. So we'd like to have those domain resolvable on Vagrant as well. We use DNS mask as a DNS relay, as console listens on a non-standard DNS port. So you have to relay DNS queries somehow to console. So we use DNS mask for that, so which basically works the way that if there's a request to console domain, it goes to console. Otherwise, it goes to Google DNS, for example. To enforce that, so to point your machine to that DNS mask instance, we have a custom etcresolve.conf file, which basically means that we have a single, actually two lines there. The first is name server localhost, which points DNS query first to DNS mask, and there's also a fallback one if something is not right with DNS mask, so we go directly to our company DNS server or to Google DNS or whatever. When you run Vagrant, you also have to remember that whenever you join a network, most probably you get a DNS server out of DHCP server. So whenever you do things like service network restart, your etcresolve.conf file will be overwritten automatically. So we have to have a way to prevent that, and there's a way to do that. You have to set a custom file under etc DHCP client enter hooks. And that file should look really, really simple. But the problem with that was that we had a lot of issues, especially on Windows boxes, that it worked fine on OS X, it worked fine on Linux, but people reported that that console doesn't work, as you can't resolve things, as the etcresolve.conf file is different than it's supposed to be. So here's the line you have to add to prevent changes in etcresolve.conf file. But on Windows boxes, we got this kind of error. So there's a error on line 1 near the bracket sign. And what can be wrong with this? This is like 3 lines of configuration. But it turned out the issue was not with Chef, not with Vagrant, not with console, not with DNS mask. The issue was around end-of-line characters. People used to forget about setting that in their global git config file. And instead of Linux end-of-line characters, you get the Windows one. So bash or shell, any kind of shell you use, can't evaluate that, and it sees error at the first line, at the end of the first line. And you can enforce particular schema for end-of-line characters via git attributes file. And that's kind of a standard for us these days. This is one of those things that you can drive you mad really quickly, as this is just an example. We had a similar cases for things like, I don't know, that when you display content of the file, it gets displayed or not, depending on what kind of platform you run. So that's kind of crazy. So you should definitely do that. There was also some issues with Chef. So we started our journey with Chef Solo. There was no Chef Zero at that time. But we switched over when the Chef Zero came in. Chef Zero, for those of you who don't know, is an in-memory Chef server. So first, it spins up a really lightweight version of Chef server and uploads all the artifacts into memory. So we have like a local version of the Chef server. You don't have to spin all the services. You have like a very small binary that does just that. But there is an issue with that. So I recently opened a ticket that Chef Zero spends like 3 minutes doing nothing, especially for long run lists. So we have like, if you have like 20 recipes on your run list and you try to use Chef Zero as a provisioner, you will have to wait like 3 minutes waiting for nothing, as there's a bug there. I don't know what it's all about, but clearly something is wrong there. So eventually we switch over back to Chef Solo again, and we don't have to pay the penalty of that 3 minutes wait for nothing. Third thing we implemented, we reduced amount of plugins to absolute minimum. So we used to have like things like that Vagrant Berg shelf plugin, the Omnibus plugin that downloads Chef client. We got rid of that. And we leave actually just a single plugin for now that manages etc host files. So the local domains are basically resolvable for you guys on local machines. So if you can get rid of some plugins, do it. It will make your Vagrant file faster. There's also a couple of useful helpers. So if you require a very specific version of Vagrant, don't leave the default value, which is like greater than 1.50, if I remember correctly. Just make sure it is right, as people used to forget about downloading very specific version you need. For a very long time, we relied on 1.7.4 version of Vagrant, as there were some changes in 1.8 related to Chef. So we had to stay on 1.7.4 for a very long time, but people still installed 1.8 and wondering what was wrong with that line. Every single Vagrant command you execute will tell you that you're running the wrong version of Vagrant, and you have to either downgrade or upgrade. There are also two helpers that are very similar. Actually, no, they are not similar. The first is about plugins. You can check whether the plugin is installed or not and take an action. So if someone forgets to install a plugin, you can skip that as you check if the plugin is already there or not, depending, of course, on the plugin. Sometimes some plugins are really required, but some of them are optional. And you can also do things like, recently there was a linked clone implemented in Vagrant, which significantly increases the speed of the first Vagrant app, as there's a base box that gets uploaded, and there's like a snapshot created. So instead of like waiting like 20 minutes or 15 minutes for import, you spend like 30 seconds for the snapshot to be created. So we can use that. That was specific to Vagrant 1.8. So you can, if Vagrant version matches to 1.8, then do that. Otherwise, don't set that linked clones in your Vagrant file. And that would be it. That's all I got. If you have any questions, I would be more than happy to answer them.